This model question is regarding the ozone depletion. The formation of the ozone hole in the Antarctic region has been a cause of concern. What could be the main reason or reasons for the formation of this hole? Now, ozone hole means those regions where we are having most thinning of the ozone layer taking place. That region we call it as ozone hole, right? In the polar regions, right, especially in the Antarctic region, we are having the ozone hole taking place. I mean, if you compare with the equatorial and other regions, right, the ozone hole is more prominent in the like the Antarctic regions. Plus, we are also having the ozone hole in the Arctic region, right? So, like this question is regarding the reason for this ozone hole specifically on the Antarctic region. So, we have been given three options here. The first one, the presence of prominent polar front and stratospheric clouds, right? So, like what I mean here, what we mean by polar front, it's a region in the mid-latitude region more near to the subtropical low pressure belt. Now, in a low pressure belt, as you have seen in some other videos, you must know that the low pressure regions, we will be having the convergence of wind, and wherever we are having convergence of wind, the wind will always rise up. So, in the earth, I mean, if you look at the pressure belt, we are having two low pressure regions, one the equatorial low pressure belt as well as then we are having subpolar low pressure belt. I mean, both in northern hemisphere as well as the southern hemisphere, right? In both of these regions, what happens is that the winds are converging and they are rising up. And in this region we call it as polar front. For the reason, in this region we are having convergence of two different types of air masses. In the sense, one, the easterly winds coming from the polar regions will be carrying the cold air mass towards this region, right? At the same time, the westerlies coming from the southern hemisphere, they will be bringing them with the warm tropical air mass with them, right? So what happens is that the subpolar low pressure belt, these convergence of winds means we are having the convergence of different air masses, right? So regions having convergence of different air masses, we call it as front, and in this region, right, this we call it as polar front, where the cold air mass from the polar regions converge and the warm air mass from the tropical regions converge. Now, you might think how this is related with the ozone depletion. Now, think about this general circulation of atmosphere in the sense, in the equatorial region, think about we are emitting large amount of, say, like chlorofluorocarbons. What happens is that they will rise up, right? They rises up, then they are subducting in the subtropical high pressure belt, and one part of the air is again going towards the subpolar low pressure belt, and it's again getting uplifted, right? So in general, what happens is that the air is circulating. It's not like, the air is staying stagnant over one region. For this reason, the emissions, the ozone depleting substance emitted from one region, be it anywhere in the Earth's surface, at the end of it, it will reach back to the polar regions. Now what happens is that since we are having the polar front here, the air masses will, the air will get uplifted, and for that reason, these ozone depleting substance will be more towards the stratosphere. More chances for them to reach the stratosphere is there in the polar front region, right? Now you might think why it is not there in the equatorial regions, even though we are having rising up of the air. In the equatorial region, we are having more dynamic conditions. So the rising air, it will be brought back to the polar regions. And in the polar regions, right, as the air is rising up and it is going towards the polar regions, what happens is that more ideal conditions will take place. In the sense, the air is lying stagnant over these regions in North Pole as well as near to the South Pole regions. For this reason, right, this results in a particular type of cloud which is called as polar stratospheric cloud, right? Generally, the clouds are limited to the troposphere. We are not having clouds in the stratosphere. But this is one exception is there, which is polar stratospheric cloud. So this polar stratospheric cloud, they are generally made up of ice crystals, right? They are like, they are the clouds which are towards the polar regions. So what happens is that due to the presence of polar front, the ozone depleting substance will get uplifted, and when they reach the polar regions, they form the polar stratospheric clouds, meaning that all the ozone depleting substances, they will get trapped inside this stratospheric cloud. They'll lie near to the polar regions itself. And when the next season comes, when we are having more temperature reaching the polar regions, say during the summer time or like during the spring period, if you're having more sunlight reaching the polar regions, this ice crystal will start to melt. Okay, the stratospheric clouds will start to melt, and what happens is that the ozone depleting substances trapped inside the stratospheric clouds will result in the depletion of the ozone here in the northern pole as well as southern pole, right? So this is one reason why we are having the ozone hole more prominent over the Antarctic region. The presence of prominent polar front and the stratospheric clouds, right? So answer should be having 1 in it. We can eliminate C, right? And the next one, general circulation of atmosphere and inflow of chlorofluorocarbons, which you have already found, which you have already seen, right? The general circulation of atmosphere here means like, the air is rising up from the equatorial regions, then it's subducting in the polar subtropical high pressure belt, and then it's again getting uplifted in the subpolar low pressure belt, right? So in effect, the general circulation of atmosphere means, like from the term itself, right? General circulation of atmosphere. The air is not stagnant, rather than it's being circulated, right? So due to this general circulation of atmosphere, all the ozone depleting substances will be brought to this polar regions, right? So again, the second option is correct, like general circulation of atmosphere and inflow of chlorofluorocarbons, meaning that this will get trapped inside the stratospheric cloud, which can cause the ozone depletion. Again, the second statement is also correct. We can go through the option. D as well as A is having 1 and 2 in it, right? Anyway, we need to know the third statement. And the increased temperature at polar region due to global warming. Now you have to keep in mind, the increased temperature at the polar region is not contributing to the ozone depletion. Rather than it's the lower temperature, the colder temperature there is resulting in the depletion of the ozone hole. In the sense, if we need more colder temperature for the formation of stratospheric clouds, and these stratospheric clouds actually trap the ODS substances, right? The ozone depleting substances. So the third one, increased temperature at the polar regions is not actually causing the, is not the reason behind the, depletion of the ozone layer in the Antarctic region. For that reason, the answer here comes out as A, which is 1 and 2 only.